Hi, now let us go through an example of the chi-square test for independence. So in the previous video, we looked at steps for hypothesis testing, we reviewed those. And in this particular video, we are going to go through the same steps, but using specifically the chi-square test for independence. So there are several things that have to be in place before you can conduct a chi-square test for independence. And we have to meet those requirements, right? And there are 5 of them. So the assumptions that have to be met, or the requirements for a chi-square test. So requirements to be met for a chi-square test to be valid, right? So there are 4. Let's just discuss them quickly. Number 1 is that the variables, like I said in the first video of this series, the variables must be categorical. So variables must be categorical, meaning that they have to be nominal or ordinal. Nominal or ordinal. Number 2 is that the variables must have at least 2 categories, right? So variables must have at minimum, right? So at least 2 categories, right? So what this means is, if you have a category like let's say income, it has to be broken down into at least 3 categories. Maybe you have high income, middle income, and low income, right? So those are 3 categories. A variable like gender has 2 categories, can be male, female. It can be made into 3 categories or even more if you have male, female, other, right? So that's what we mean them. And then number 3 is that, requirement number 3 is that we will later on calculate or work on something called expected frequencies. So not more than 20% of cells should have expected frequencies of less than 5. Right, so 20% or less than 20% of cells must have expected frequencies less than 5. Right, so expected frequency, we'll look at what this is later on. Expected frequency less than 5. Okay, so what this means is we have to have a reasonable sample size, right? So this is the reasonable sample size requirement, which means a large enough sample size. And then requirement number 5 is, if you have any cells that have frequencies that are less than 5, then they shouldn't be less than 1, right? So no cells at all, no cells should have expected, right? Again, we are talking about expected frequencies, not the observed. Expected frequency less than 1. Right, so those are our requirements. So if we meet those requirements, then we'll go on to conduct a chi-square test. So the next thing I will do is I will put on the table that we are going to use, the table that we constructed in the first video. What we are going to do here is we'll go through the steps that we follow for hypothesis testing. Okay, step 1. So remember that step 1 is to define our hypothesis, right? So we have the null hypothesis and the alternative hypothesis. So our null hypothesis, since we are testing for independence here, so our null hypothesis will be that there is no association between gender and exercise. So that's our null hypothesis. There is no association, right, between gender and exercise. Those are our variables, gender and exercise. The other way to write this would be, okay, if you prefer to use the word independence, right, you may say that gender and exercise are independent. Gender and exercise are independent. And that's what we are testing. We are testing for independence. We are testing the null hypothesis that these two are independent. That's why it's called the chi-square test for independence. And then the alternative hypothesis, which is H sub 1, would say that there is an association between gender and exercise. Okay, so there is an association between our two variables, gender and exercise. Another way to say it, again, if you are going to use the word independence or the word dependence, then you can say gender and exercise are dependent. Okay, so gender and exercise are dependent. Okay, so that's that. So if you are going to be, let's suppose that this was a study or a research, you would have something called, let's say, a research question. Let's suppose that we have a research question. We can frame it as, is there an association between gender and exercise among adults, right? So you may find that this comes from maybe a specific population, right? And so a more complete question would be, is there an association between gender and exercise among adults or among adult residents of a given maybe city or a given geographic area? Okay, so just as an example, I'll write this down as, is there, so that's our research question, an association between gender and exercise among adults in, let's say, a city or a town, Francistown. So this becomes our research question, and then we frame this research question in the form of a hypothesis, and then we test that hypothesis. Then we get our answer at the end, whether there is a significant association between these two variables. So in our hypothesis testing, step 2, we have to define our level of significance. And this is easy because level of significance is usually set to 0.05. The chance of a type 1 error, right? So the alpha level is the probability of a type 1 error. So we are talking about a type 1 error, okay, which is the probability of rejecting the null hypothesis given that the null hypothesis is true. In step 3, then we calculate our sample statistic. So step number 3, we calculate our sample statistics. What we need for a chi-square test, okay, is that we need to create another table which would show us the values for our expected frequencies. Okay, so this here, up here, are our observed frequencies. So we need basically another table that would show us the expected frequencies in the event that the null hypothesis is true. So that's what we are doing. So in the event that the null hypothesis is true, or given or assuming that the null hypothesis is true, indeed there is no association between gender and exercise, what kind of table would we expect to get? And the way we are going to do that, there is a formula that we use to get the expected values, and that formula comes directly from the multiplication rule for independent events, and it's given by E for expected. So the expected value, right, expected value is going to be given by, so let me do this, the expected value is going to be given by the row total, right? I'll just abbreviate this as RT. So row total, okay, times column total divided by the grand total. Okay, so the grand total in our table is 63. So that's our grand total, right? Our grand total is 63. That's our sample size. And then the row total and the column total will change depending on which row and column are we talking about, right? Right, so let's just go through that calculation and get the expected values. Right, we'll call this cell 1, right, just for the sake of orientation, so that we orientate our work and we orientate ourselves. So this is 1, this is cell number 2, this is cell number 3, and this is cell number 4. So the expected value for cell number 1 is equals to the row total for that cell, which is 15, rather which is 24, times the column total for that cell, which is 29, right, divided by the grand total, which is 63. And then the expected value for the second cell, which is this one here, the row total is 24, the column total is 34, right? So row total 24, column total 34, we divide by 63. Okay, so I think it's now obvious what's happening here. So I'll just complete the rest quickly and then we'll get our values. Right, so in step number 4 for our hypothesis testing, remember that step 4 we're saying we get the test statistic. So we calculate the test statistic, right? And then for the chi-square test for independence, the test statistic is given by the formula that we covered in the previous video. Chi-square is equals to the sum of our observed frequencies minus the expected frequencies squared divided by the expected frequency, right? So what happens here is we take each cell, we look at the observed frequencies, we minus the expected, we square that, we divide by the expected, and then we sum those cells. So we have 4 cells, which means we are going to do this 4 times, then we get the total. That total is our chi-square value. You can do this in 2 ways. You can use a table or you can do it the way I'm going to do it here. So the first cell, right, if you look at the first cell, the observed is 15. So it's going to be 15 minus the expected, which is 11.048. So 11.048, right? We square that, squared, we divide by the expected, which is 11.048. Okay, that's for the first cell done. And then we move to the second cell. The second cell, the observed frequency is 9 minus the expected frequency is 12.952. So 12.952, we square that, then we divide by the expected, which is 12.952. Right, so I'm going to complete this for the rest of the cells, and then we will add them and get our chi-square value. Okay, so here we are. So our chi-square is going to be, so now if we work on this, simplify it, it will give us 1.414 plus 1.206. That's the second one here. Third one is 0.870 plus 0.742, right? So if we add those, we get a chi-square value of, which is a test statistic, right, of 4.323. So that's our chi-square value. That's our test statistic. Okay. So having done that, now we can move on to calculating our p-value. So that's step number 5. So in step number 5, we calculate the p-value. Right? There are two ways to test for significance. One way is the p-value method. The other one is the critical value method. So for the sake of completeness, I'll just show you both methods here. The first thing we need for the p-value is our test statistic, right? So we have our test statistic, which is 4.323, and then this is our chi-square value, right? And then we need degrees of freedom. Okay, we need degrees of freedom, and then the degrees of freedom for a chi-square test for independence are given by this following formula. It's the number of rows minus 1 times the number of columns minus 1. And remember that you don't count the column total and the row total. So in this particular table, we have 2 rows. So it's going to be 2 minus 1. And we have 2 columns. So 2 minus 1 as well. That's 1 times 1, which is 1. So the degrees of freedom for this particular test is 1. Okay, so we need these 2 pieces of information for our chi-square distribution table, and we'll look at it next. So as I said, there are 2 ways to do significance testing. So the first thing I will do, instead of doing the p-value method first, I will just quickly cover the critical value method first and show you how it works, right? So for the critical value method, we basically compare our chi-square value with a critical value at the chosen level of significance. Okay, so this is our chi-square distribution. So the critical value, remember that our alpha level, okay, so our alpha level is 0.05. So this is our alpha level here, 0.05. And this alpha level corresponds to a critical value of 3.84 at 1 degree of freedom. Right? You can see that these are the degrees of freedom. We are working at 1 degree of freedom in our example. So if we go across to 0.05, our critical value at 1 degree of freedom is 3.84. Okay, so we mark 3.84 somewhere on our table, on our graph, 3.84, right? And then anything beyond this point, we reject the null hypothesis. So this is called the critical region. So this is our critical region. If we look now at our chi-square value, our chi-square value is 4.323. So 4.323 would be on this side, on the right side of our critical value, which means that we have to reject the null hypothesis, right? So our value, our chi-square calculated value is somewhere in this region. Chi-square is equals to 4.323. Okay, so it's in the rejection region. So we would conclude therefore that the null hypothesis, or rather we reject the null hypothesis, meaning that there is evidence to show that there is an association between gender and exercise. Okay, so that's the critical value method. But for us, I want us to look at the p-value method, mostly because that's the one that's reported in journals and in research generally. So our p-value is going to be also given by the table. So if you look at these numbers, these are our probabilities. Okay, it says here that probability of a larger value of chi-square. So these are basically our p-values here. So what we do therefore, we take our calculated chi-square value, this 4.323, and then we see where it lies, okay, at 1 degree of freedom. So we go to 1 degree of freedom, that's our row. Then we go across, right? So we have 0.016, 0.102, we have 0.455. We still have to go further. We have 4.71. We have 3.84. Okay, we are getting closer. And then we have 6. So it means that, remember, these tables are estimates. So it means that our chi-square value, the calculated value, our test statistic, lies somewhere between this number 3.84 and this number 6.63, right? So those two numbers correspond to a p-value of 0.05 and 0.01. So these are the p-values that correspond to these two numbers between which our chi-square value lies, right? So by extension, we therefore know that the exact p-value for our chi-square value, calculated chi-square value, is somewhere between 0.05 and 0.01. So therefore, our p-value is between 0.01 and 0.05. We know for sure that our p-value is less than 0.05 because if it's between 0.05 and 0.01, it means that it's less than 0.05. We can therefore conclude that our p-value, right, so this is step number 5, remember? So from the table, our test statistics falls between 0.05 and 0.01. Therefore, p is less than 0.05. That's the important information we need there. We don't need the exact value of p. We just need to know whether or not it's greater than 0.05. And we can see here that it's less than 0.05. Step number 6, we make the decision based on, or we make our decision based on the p-value, right? So we would say our p-value is less than our alpha. Alpha is equals to 0.05, okay? And therefore, right, therefore, we reject the null hypothesis. We reject the null hypothesis, okay? And then step number 7, so we would conclude that there is enough evidence from our sample to demonstrate an association between gender and exercise. Another way to say it, if you want to use the word dependent or independent in your conclusion, you may say there is enough evidence to show that gender and exercise are dependent. Okay? So gender and exercise are dependent. Another thing to note, just as a side note, is the chi-square test or the p-value doesn't tell us the strength of this association or the strength of this relationship. It just tells us there's a relationship or not. It's a yes or no kind of question. Great. So the next thing we are going to do now is let's run the same test in SPSS. And you'll see how easy it is for SPSS to do this. When doing it by hand, you can see that we took quite a while to go through the calculations and also use the table. And the table gave us a p-value that wasn't exact, right? So in SPSS, we'll do the same, and then we'll get an exact p-value, and you'll see how quicker it is with SPSS. Right, so here we are in SPSS. The data file that we are using is the same one that we used for the previous video, which was part 1, and the data set is called health status. It has 6 variables: gender, X-benefit, systolic blood pressure, exercise, weight, and height. Okay, so to perform a chi-square test for independence, we go to Analyze, we go to Descriptive Statistics, cross tabs, because we need a cross tabulation, right? And we are going to create the same table that we saw in our example. So we need on the columns, right, on the independent variable, we need gender. So gender will go on the columns, and then do you exercise regularly will go on the rows. Okay. And then what we need also, if you want to see the expected values, right, then you go to this option here which says cells, right? So if you click on that, you'll see you have counts, and under counts we have observed, and then we have expected. So you check expected there, so that it gives you within the cells, it gives you the expected values as well, not just the observed, right? Remember that we had to calculate these by hand, but you can also get these in SPSS. We need to tell SPSS, right, under statistics, we need to tell SPSS that we are doing a cross tabs, and under cross tabulation we also want the chi-square value, right? We want a chi-square value, and so we test, we also take that option, then we continue. Right, so from the output you can see that SPSS always gives you, first of all, case summary. You can see that we have 63 participants, none are missing. Then the second table, it's a cross tabulation, right? You can see that we have the observed count, right? So this is the observed frequency, and then underneath that we have the expected frequency. So the third table there gives us the chi-square test result. Okay, so the first number that we have, you can see we have 4.232, right? So this is the PSN chi-square is 4.232. We won't concern ourselves with the other numbers because we haven't really covered them in this video. They are not so important for us. The degrees of freedom is 1, like we got when doing this by hand. And then this column here, which says asimp sig two-sided, this gives us the significance, right? So this is our p-value, right? You can see that the p-value is 0.040. Remember that for hours we were using a table and we estimated it to between 0.01 and 0.05. What's important here is that the p-value is less than 0.05. and therefore our finding is significant. Indeed, there is an association between exercise and gender. So that's it for this series of videos on the use of a contingency table, probability, and the PSN chi-square test for independence. I hope that this video was useful, and if you found it helpful, subscribe and click the notification bell to get more videos like these. Like and share the video, and feel free to leave a comment or question below.